In this video, I will go over the homework that follows the lecture 10.2 that covers another inverse trigonometric substitution of this pattern. And as always, I hope you watched the lecture, and let's jump right into the homework. The first problem is definite integral, and we have limits from 10 to 14, 1 over square root of 16 x squared minus 10, 24 dx. And now the pattern that we explore in here is the following. We have b squared x squared minus a squared, and we have 4 squared x squared minus, what is this, 32 squared. And therefore, recognizing this pattern, we are going to try this substitution. And the substitution is x will be set to 32 over 4 secant theta. In other words, it is equal to 8 secant theta, and therefore dx will be 8 secant theta tangent theta d theta, and therefore square root of 16x squared minus 10, 24 will be equal to 32 tangent theta. And we're also going to state the following fact, that secant theta is x over 8. Therefore, we can construct the following reference triangle in case if we need it. For definite integrals, it's very likely that you will not be required to use it, but for this particular problem we are going to need it. So it's always better to have it and not use it than need it and not to have it available. So by Pythagorean theorem, this will be square root of x squared minus 64. And because it's a definite integral, we need to also acknowledge that theta is equal to arc secant of x over 8, and therefore when x is 10, theta will be arc secant of 10 over 8 and arc secant of 14 over 8. And just for the sake of saving some time writing those limits out, I'm just going to refer to them as a and b. And now, having done all this preliminaries, we now ready to continue with the main integral and substitute everything in. So we have an integral from a to b of 1 over 32 tangent theta times dx, which is 8 secant theta tangent theta d theta. And reducing everything gives us 1/4 integral from a to b of secant theta d theta, which is an easy one. We know what it is. It's going to be 1/4 ln of secant theta plus tangent theta, and we're going to evaluate it from a to b, but a is arc secant of 10 over 8, and b is arc secant of 14 over 8. So plugging that in gives us 1/4 ln of secant of arc secant of 14/8 plus tangent of arc secant of 14/8 minus, so now we're going to have minus 1/4 ln of secant of arc secant of 10/8 plus tangent of arc secant of 14/8. And here we need to, ideally we would want to just be able to plug it in and compute it, but this time it's asking us to actually find the exact answer. So what we're going to do is we're going to compute this, and secant of arc secant just simplifies. So here we have 14/8 plus here we have tangent of arc secant, which we're gonna take care of, and we have minus 1/4 ln of, it's going to be 10/8 plus, and here we're going to have tangent of arc secant of 4, this should be 10. Now the question is, what is tangent of arc secant of something? And let's go over here and let's acknowledge that tangent of arc secant of 14/8 is going to be the same as tangent of theta, but when x is equal to 14. And tangent of theta when x is equal to 14 is tangent is opposite over adjacent, so it's going to be square root of x squared minus 64 over 8. So we're going to write here square root of 14 squared minus 64 over 8. And similarly, tangent of arc secant of 10/8, it's the same as tangent theta, but when x is equal to 10. And you can see that that will be equal to 10 squared minus 64 square root over 8. So square root of 10 squared minus 64 over 8. Now we can simplify this expression by combining the natural logs, and because everything is positive, we have 14 plus, we don't need the absolute value when everything is positive, and here we have in the denominator we have 10 plus 10 squared is 100, 100 minus 64 is 36, so we have 10 plus 6, and in the numerator we have 14 squared, which I think it's 196, and 196 minus 64, it's 132. So it's possible that we can simplify it, but we don't need to. So let's go ahead and enter the answer. and it's good. All right, let's go ahead and try the next question. We have indefinite integral. We're exploring this pattern. And we have 7 squared x squared minus 21 squared. That's what we observe. And when we observe such pattern, we proceed with the following substitution. We replace x with 21 over 7 secant theta. In other words, x is equal to 3 secant theta, so that dx is equal to 3 secant theta tangent theta d theta, and square root of 49 x squared minus 441 is equal to 21 tangent theta. And then we can acknowledge that secant theta is equal to x over 3, which is hypotenuse over adjacent, and we can draw the reference triangle. This is x, this is 3, and this will be square root of x squared minus 9. And we're ready to do the substitution. So our integral now becomes still indefinite, right? So we have 1 over 21 tangent theta times dx times 3 secant theta tangent theta d theta, and we reduce everything we can, and we end up with a very simple integral. So we have 1/7 of integral of secant theta d theta, which we know and the last step is to substitute theta with the expression containing x, and to do that we're going to use the reference triangle. So instead of secant theta we'll put x over 3, instead of tangent theta we'll put opposite over adjacent, which is square root of x squared minus 9 divided by 3, and that will be the final answer. Let's do another indefinite integral. And because of this pattern, we know that the following substitution will work. Setting x to be 16 over 2 secant theta, or in other words 8 secant theta, will make dx to be 8 secant theta tangent theta d theta, and the square root of 4 x squared minus 256 will simply become 16 tangent theta, and secant theta will be x over 8, or hypotenuse over adjacent, so the following reference triangle may be necessary to have. And now we have everything. And let's plug everything in. So the original integral now becomes this. We have 16 tangent theta times 8 secant theta tangent theta d theta. Factoring everything out, 8 times 16 is 128. And we have secant theta tangent squared theta d theta, which has this distinct pattern that we covered before, integrating products of powers of secant and tangent when secant is odd and tangent is even, is done by substituting tangent with secants. So we're going to replace tangent squared we're going to substitute tangent squared with secant squared theta minus 1. So now we have an integral made of two powers of secant, each of which is pretty straightforward. So we also learned them earlier in one of the earlier lectures. So we have 128. Integral of secant cube is 1/2 secant x tangent x. And, well, by the way, shouldn't we know? Why don't we just, I don't know, well, yeah, never mind. I was gonna, for some reason I thought integral of tangent cube will be relevant here, but it's not. So here we just continue with integral of secant cube plus 1/2 ln of secant x plus, and at some point I start writing x's when I have thetas. And the integral of secant theta is just ln of secant theta tangent theta, but if you have plus 1/2 of something and then minus 1, it just becomes negative 1/2. So here I'm just gonna change this plus 1/2 to negative 1/2. And the final step is to, let's take out 1/2, so we have 64, and now we have to plug in everything for theta to make it in terms of x. So secant, instead of secant theta, we'll be plugging in x over 8. But instead of tangent theta, we'll be plugging in the opposite over adjacent, which is square root of x squared minus 64 over 8. And that's going to be the final answer. And we can distribute 64 over, actually. That would look nice. X square root of x squared minus 64 minus 64 ln and we got it. So this was problem number 3. Let's go to number 4. Here we still have the same pattern, right? So we have b squared x squared minus a squared. In this case, we have 6 squared x squared minus 12 squared. With that pattern in mind, we are going to try this substitution. And we're going to replace x with 12 over 6 secant theta. So dx will be 2 secant theta tangent theta d theta. Square root of 36 minus 36x squared minus 144 will automatically become 12 tangent theta. This is definite integral, so we are going to do two things. We're going to say that secant theta is equal to x over 2, meaning that theta will be equal to arc secant of x over 2. So to change the limits, when x equals 7, theta will be equal to arc secant of 7 over 2, and when x equals 8, theta will be equal to arc secant of 8 over 2, and just for shortness, I'll be labeling it as a and b. And also, just in case, we may need a reference triangle, so I'm going to call this secant theta is the hypotenuse over adjacent. So I'm going to also construct the reference triangle here. So this is my theta, this is my adjacent, hypotenuse and opposite. So I'll label this x, label this 2, and this becomes square root of x squared minus 4. And with all of this preliminary steps being done, now we're ready to actually do the substitution. So this original integral now becomes integral from a to b of 1 over 12 tangent theta times 2 secant theta tangent theta d theta, reducing everything, and we have a rather simple integral, and its antiderivative is ln of secant theta plus tangent theta, and we're going to evaluate it at a and b, but a is arc secant of 7/2 and b is arc secant of 8/2. And let's plug everything in. So here we have secant of arc secant of 8/2 plus tangent of arc secant of 7/2 minus 1/6 ln of secant of arc secant of 7/2. I keep making this mistake. Like, this is 8/2 all the way, And here we switch to 7/2, but all the way. So we have arc secant of 7/2. Now, secant of arc secant, it's pretty straightforward. So we're going to have 8/2 here. And here we're going to have plus tangent of arc secant of 8/2 minus 1/6 of 7/2 plus. The main question is, what's tangent of arc secant 8/2 and arc secant 7/2? And for that, we're going to go right over here. And we're going to notice that tangent of arc secant of 8/2, it's nothing but tangent of theta when x equals 8. But tangent of theta is opposite over adjacent. So we want to write here square root of x squared minus 4. But instead of x, we're going to write 8. And we divide it by adjacent, which is 2. And similarly, we find the tangent of arc secant of 7/2, which is tangent of theta when x equals 7. So it's going to be 7 squared minus 4 divided by 2. Now we combine it into a single logarithm. There is no need for absolute values because everything is positive, and we can get rid of all the 2's because it's in the numerator and the denominator, and we end up with the following. And that's the final answer. And we are done. So if you have any questions about this particular inverse trigonometric substitution, let me know.